Okay, so this question, we can recognize this as the derivative of 1 over x at x equals 7. This is the slope of the tangent line of 1 over x at x equals 7, because we have f of x minus f of c, in this case where c is equal to 7 over x minus c. And this is the limit as x approaches c. Okay, remember that what we're doing is we're taking y2 minus y1 over x2 minus x1. We're taking the average rate of change between 2 points, and then we're taking a limit as those 2 points basically become the same point. So now we have the slope of a tangent line. So we can actually evaluate this limit by using L'Hopital's rule, and I'll talk about another way to do it really quick too. So first of all, if we recognize this is the derivative of 1 over x, then we can just say that we're looking for f prime 7. Okay? So d dx of 1 over x is equal to, well, really quick, x to the 1 over x can be rewritten as x to the negative 1. So if we do power rule on that, we're going to do negative 1. It's going to jump out in front, and then we're going to drop the exponent down by 1. So we're going to get negative x. The negative is coming from multiplying by negative 1 to the negative 1 minus 1, which is negative 2. So we get negative 1 over x squared. We're taking f prime 7, so we can take that 7 and just plug it in right here. So we're going to get negative 1 over 7 squared, which is negative 1 over 49. Okay. The other thing we can do is we can do L'Hopital's rule, which is essentially going to be the same thing. So we can't take this limit right now, because if we plug in 7, we're going to get 1/7 minus 1/7 over 7 minus 7, which is 0 over 0, which is indeterminate. So what we can do is we can do the derivative of the top and then the derivative of the bottom, and that will be equal to the limit we seek. So we have the limit as x approaches 7. The limit of the top is just negative 1 over x squared. We already did that derivative earlier, and we've done it enough that eventually it's just going to become second nature. I'm realizing that this arrow is looking a lot like a 7. Oh no. Okay, this is an arrow, this is a 7, as x approaches 7. Okay. The derivative of the bottom is just x. Of x is just 1. So then we just get negative 1 over x squared. We're going to plug in 7, so we're going to get negative 1 over 7 squared, which is negative 1 over 49. Okay, see in a couple different ways, but that is our answer. The slope of the tangent line at 1 over x at 7 is negative 1/49. And also, if we just forget about this being a derivative and evaluate it as a limit, we use L'Hopital's rule, and we still get negative 1 over 49.